Hey folks, this is your introduction to hyperbolas with all of the parts labeled. First thing, notice that I have two hyperbolas drawn here. One of them opens side to side, or it opens horizontally, and the other one opens up and down or vertically. We'll talk about that matching up with our equations in just a moment. Now, to label the bits and the pieces, a lot of these are going to be similar to things that you've already studied. The first thing that we have is the center, also called HK. The second thing is going to be our transverse axis. Transverse axis is this axis here that cuts the hyperbola in half, and it actually intersects the hyperbola. Thirdly, we have the conjugate axis, and this is the axis that does not touch the hyperbola itself. It goes in between the two pieces of the hyperbola. One note about the transverse and the conjugate axes, back in the ellipse, the major and the minor axes, one was always longer than the other one. However, that's not the case for the hyperbolas. The transverse axis might be the longer, the conjugate axis might be the longer. The next thing that we have here is going to be the two vertices. And then after our two vertices, we also have our two focus points. And then lastly, something new is the asymptotes. Remember that asymptotes are like a fence. It's something that you're always getting closer and closer and closer to, but you don't actually reach it. Now I have three more things that I want to point out, but I'm going to do that on the other picture simply because I was running out of space. The first thing that I want to point out is distance A. This is the distance from the center to the vertex. And then I have distance B. This is the distance from the center to the end of the conjugate axis. And lastly, distance C from the center to the focus. You'll notice that if you go down below, I have three starred statements that show that very thing. Vertices are always going to be A away from the center. Endpoints of the conjugate axis are always going to be B away from the center. And the foci are always going to be C away from the center. The last thing I'd like to take a look at is the two equations. You'll notice this time that it's the denominators that are identical, but the numerators are what's different. So let's point out a few differences on the numerators. Each of these have a positive term and a negative term. So in this first one, my x's are positive while my y's are negative. It's the positive term that determines the opening direction. So you'll notice since my x's are positive, my hyperbola is opening along the x's. It's opening horizontally. In the other example, my y's are the positive term, so my hyperbola opens vertically. It opens along the y direction, up and down. The last thing to point out is another one of these small equations. A squared plus b squared equals c squared. And again, just like with the ellipse, I call this guy the little dude. And the only time that we ever use little dude is when I need to work with the focus points.